Hey everyone, welcome to talk show number 16. Have you ever wondered how much carbon your car trip actually takes? Well, it's actually very easy to do a back of the envelope computation of it. Let's check it out. Let's do a computation of the carbon footprint of riding a company shuttle from San Jose State University to LinkedIn. And this journey is 12.3 miles. It's only 13 minutes at this time of day, but I can assure you it's a lot longer during rush hour. So the first number you want to know is how much fuel the bus consumes per a certain distance. So here we are. According to this source, which is the Electrical and Mechanical Services Department of the Government of Hong Kong. Very interesting bureaucratic department. Let's scroll down here. So we can imagine that the company shuttle is a private bus that's a single deck. And according to this website, it's 23.5 liters of diesel per 100 kilometers traveled. Now, I'd take this number with caution because this number wouldn't make a lot of sense if for those 100 kilometers you were stuck in traffic for a long time, because your vehicle continues to burn fuel even if you're idle, right? I'm not sure how they got this number, but this is why the computation's back of the envelope. So let's do 23.5. Okay, let's save that number. Then we need to convert liters of fuel to carbon dioxide somehow. How do we do it? So diesel has a huge carbon component, and as we can see from the Wikipedia article, about 86.1% of the fuel mass is carbon. Now let's be careful here, right? Because we're talking about liters, so we have to first convert liters to mass. So here we have the density, so we can multiply the 23.5 liters times 0.832. So now we have kilograms of fuel. So 86.1% of a kilogram of fuel is carbon, so we multiply by 0.861. And then finally, because there's 1 mole of carbon and CO2, and we have just the carbon quantity, right? So then we need to see how many kilometers 12.3 miles is, and so it's 19.79 kilometers. So we travel 19.795, and this is per 100 kilometers, right? So at the end, we see that for this one-way journey, it takes 3.3 kilograms of CO2 to make this trip. Well, it turns out that this 3.3 does not refer to kilograms of carbon dioxide. It refers to kilograms of carbon. And let's see why. So we had 23.5 liters of diesel. This converts liters of diesel to kilograms of diesel. With this multiplier, we now have kilograms of carbon. And this is kilometers, and this is also kilometers. So we actually have kilograms of carbon. Now, how do we convert this answer to kilograms of carbon dioxide? Well, for every 12 grams of carbon, there are 44 grams of carbon dioxide, because you have to include the O2 molecule in the mass. So then our actual answer is 12 kilograms of carbon dioxide, not 3.3. So it's a big difference. It's almost a factor of 4. And there are actually news articles online that have gotten this conversion incorrect before. So I hope this tutorial was really fun. It showed you that just by Googling a few numbers, you're able to get a reasonable estimate as to some really cool question, like how much carbon does your trip take. And one quick thing, by the way, to get this number from the Hong Kong government page, I just Googled bus diesel consumption per kilometer. So moles of carbon and moles of carbon dioxide are the same, but not the masses. So yeah, for your homework, wink, 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 you should compute the amount of carbon it takes to make a road trip from NorCal to SoCal. In the meantime, I'll see you tomorrow.